Hello there. In this module, we're going to learn about machine learning and how you can leverage machine learning with Azure. So when machine learning goes into the cloud of Azure, we know it call it as Azure machine learning. So let us dig into it. This is the snipe I have taken from the Microsoft AI 900 official documentation, and this is the thing which we're going to discuss in this demo. First, we're going to identify the common machine learning types. Like there are a lot of scenarios which we're going to discuss: regression, classification, and clustering machine learning scenarios. We also going to have the demos. Then we're going to discuss about machine learning concepts, like how we can train the model, how we can validate the data sets in the machine learning. Then we're going to identify the core tasks in creating the machine learning solution. That is the data ingestion and the preparation, the feature selection and the engineering which is used in the machine learning, and how we can train and evaluate the model once we fetch the data into the model. After that, we're going to deploy the model and see how it will look like when it is in the deployed state. Then we're going to discuss about no code machine learning. So there is a tool called automated machine learning. In this, you don't need to write any code. If we use this automated machine learning, then everything will be done for you without writing the code. You just need to fit the data. And then we have called Azure Machine Learning Designer, which is kind of a pipelines. In this, it's a drag and drop. We will demonstrate how we can drag and drop the various scenarios in the pipeline. We create a lot of scenarios in the pipeline and see how it will work. What are you going to learn in this module? You're going to learn what is machine learning. You'll also learn how machine learning will work. You're going to learn various modules of the machine learning like regression model, classification model, clustering model, and how machine learning on the Azure will look like. That is an Azure machine learning. After this, you want to learn that Azure Machine Learning Designer, that is a pipeline, how it will look like. We're going to discuss each and everything in detail with a demo in this session on the Azure. So it will be great if you have the Azure subscription so that you can perform the demos. Now, what is machine learning? Prediction based on the relationship between the data. We create model so that it can predict or give analysis based on the data which is available. The data which we fed to the model, it can give the results or it can predict the results based on the data which we fed. So more the data, more the efficient our product will be. Or you can say it is a technique that uses mathematics to create a model that is used to predict the feature values. In the models which we're going to discuss, regression, clustering, classification, in those, if you don't use the Azure machine learning, that is, if you're using a Python module or some any other NumPy on the machine learning, then you must have the knowledge of the mathematics because based on the mathematics formulas only the values you're gonna predict. But in this lesson, in this scenario, we are not gonna use any Python, so you don't need to worry about any mathematical function. That is all been taken care. You just need a basic experience on Azure. That's it. And if you don't have that too, in the demo, you can learn that from step by step. Now, let us talk about the first model, that is a regression. This is a machine learning model and it is based on numeric. So let us discuss that. It predicts the numerical value like sales for the upcoming month. For example, an e-commerce company can use these model to predict the sale for upcoming months based on the data from the previous sales like Black Friday sales. And if we have the data, then we can work accordingly. Let's say I have the data, I have predicted the data. Based on that data, I can have my servers ready so that there will be no downtime or there is no crash on my website. So this is how you can predict. Or after the prediction, You can have the stock of your products accordingly. So it is a very great tool to save the cost. Then, based on the analysis, the measure can be taken for better productivity. Like I said, you can save the cost based on the results you have, because it will be very great if you have already the future or the predictive value ready for you. Then you can improve the productivity of your company, of your organization. Regression is a supervised machine learning model. That is, a data set is labeled with the data available. We're going to discuss more about this in upcoming sessions. Here's an example of the regression model that we're going to discuss now. On the screen, you can see days and the sales, and there will be as 2 weeks, week 1, week 2. Each day have a different sale. Let's say for Monday, I have 59,000 products sold at my e-commerce website. On Tuesday, it's 80K. On Wednesday, it's 88K, and so on. Same as for the week 2. That is the data available. And I'm going to use this data to analyze further so that I can predict the estimated for the week 3. So in this case, I'm going to use a regression model because, as we discussed, regression is a numeric. If you see here, regression model is based on the numeric. We're going to have the numbers when the prediction is done. So here, let us consider days as X, sales as Y. So X, we can call it as a feature, that is a day. We are just saying it, just assuming it. I'm explaining you just for that I have just taken the reference. And Y is the value. Or you can say X is a parameter, normal parameter, and the value for we have a different values for each and every features, or you can say the parameter. As the day changes, the value changes because we every day it's a different sales. These two data we have so that we can predict the value for week 3. So in the regression model, how it will work, we're gonna use data for week 1 as for training the model, and for the second we're gonna use for the validation. That is, we're gonna feed the data for the week 1 into the model so that it can train based on that data which is available. But for the week 2, we're not gonna fit that data into the model. Instead, we're gonna keep it ourselves and we'll do the validation, how it works. So there's a mod we split here, we are splitting the data into two sections, dividing it so that it can be first trained, and then it is trained, we can have some data to validate that the values which is coming up is as per the prediction or not. Like I said, here data is split into two subset for validation so that when model predicts, we can match how model predicts so that we can see that our model is very efficient or it is not that much efficient. This is an analysis of the chart. I just put the values which was shown in the last diagram. Here I just put here in the below you can see the days 1, 2, 3, 4, 5, 6, 7. That is 7 days. And the values on the vertical you can say 0, 20, 40, 60, 80. That's a graph I have made. And there's a week 1, week 2. Both representation are presented in this chart. So the days are in the horizontal, that is 1, 2, 3, 4, and the the numbers are coming like 0, 20, 40, 80 like this. I have just used this data to explain you. So I just put these details which is shown in this tables, two tables, into this chart. Now we're going to discuss how we're going to do the analysis. So in this, the chart if you are seeing on the right side, is similar to this one. Like we are doing just analysis of this chart now. Here, if you can see how we will calculate the formulas if you are not using the Azure machine learning, then how it will actually work at the behind the scenes. Here in the chart, if you see for the week 1, as I am using the data for week 1, as I told you in the first one, that week 1 data will be used for training purposes and week 2 will be used for the validation purposes. So in the analysis, I will just use the yellow line, that is for week 1. I will not touch the week 2 line. Week 2 line is for just my validation once I have the formula. Now let us check how we have can get this formula. Here what we're gonna do, if you see, I have just pointed the yellow to the end of the vertical line, that is known as linear regression. I have just matched the value of the yellow line to the vertical line, and the value came somewhat similar to the 38. So I write it down as 38 as a value. Now I would like to have a slope chart, because based on that slope chart I can only have that formula for the regression. Here if you see in the middle, for every 1 day we are seeing somewhat similar to 2021, 2022, 23, like that of movement. If you see, when we move forward horizontally for a 1 day, the value is going up by 20 or so. It's an approximated value. For explaining purposes, I have just taken this value. It can vary like 20, 22. So I have just taken 20. So for every 1 day, we are seeing an estimated value of 20 movement up. That is 20 sales K up. So how the formula will become? If you see on the left hand side, the formula is like fx equals to 38 plus 20x, which means 38 is the linear regression plus 20 into x. So 20 is the value of the movement which is going, the sales is going up, and x is the value of the days. So it's pretty much simple. I will explain you again. In this we have these days, week 1, week 2. Week 1 is for training, week 2 is for validation. Once we have that, we have like graph like this. We're going to use the yellow line for the uh, training, and the week 2, that is a green line for validation. So what I did, I just matched my yellow line to the end of the vertical line, that is 38 value. That value is known as linear regression. So I put fx equals to 38 plus 20x. Okay. So now how I calculate the 20? For every 1 day of movement forward, I'm getting a 20 horizontal thing. Oh, sorry, 20 vertical. So that is a 20 value. So I put 20x. So if I want to calculate the value of function x, function fx, then how we'll get that? I'll just put a value of 1. f1 equals to 38 plus 20 into 1. That's how I'll calculate the values for the green line. That is for the week 3, and for that week 3 I will be comparing with the week 2 to check how my model looks like. So for day 1, I just put the value of x in the formula, 38 plus 20 into 1. I get the value of 58. If you see in the graph, in the table, the first estimated value is 58. So how I get that 58? That from the formula I have from the week 1, right? So I get the formula from there. Then I have to compare that 58 value with the week 2, because that green line is for the comparing with the estimated. So now I will put X value equals to 2. Yeah, means F2 equals 38 plus 20 into 2. That gives me 78. Likewise, I'll put F3 equals to 38 plus 20 into 3. That gives me 98. So that's how the value is estimated value is being generated. Once I have estimated value as seen on the chart on the left hand side in the graph in the table chart, I have all the estimated value and you can compare. For the week 2 it's 52 sales, 52k sales. For the estimated week it was 58. It will be 58. For the Tuesday, the week 2 will be 74k, and for the estimated I have the 78k. So if you see, the value is somewhat similar. Like I can have the estimation that how week 3 will be going on to be performing for my environment. So based on that I can predict the values and it will be very beneficial for me. So this is the chart. In this chart, if you see the black dots are the estimated one. If you look at that carefully, only at the fifth day, if you see on the fifth day, the chart the value doesn't seem to work well, but for the rest of the days, it worked very well. Like I have the prediction values as similar as to the accurate one, that is with the green one, that is it is very near to the green line. If you see the black dots, in most of the cases the black dot is near to the green line, so the dots are the estimated value, and I'm comparing the black dots with the green line. So if you see, it's somewhat similar with very few deficiency, so we can say that this model is very accurate. And if you would like to have more accuracy, then we need to train the model more, a bit more. Like we need to fetch the data not only for a week, for like multiple weeks, 7, 10, 20 weeks. Then then your model will perform very much better. We're gonna see in the in the demo how regression will work. Second model is the classification model, that is based on the probability. Here we will determine the probability. This model is supervised. Supervised meant that every data is labeled. We're going to discuss more about that, but for now it's a supervised means that every data in this here is labeled. That is, we are doing training and then validation. So supervised means that we have subset of data, one for the validation and one for the training. But in case of unsupervised, we have no concept like that. So we're going to discuss more about that in this similar scenario, but here we don't get any numeric values like we get in the regression. Here we get a value of 1 or 0. 1 means yes, 0 means no. As simple as that. So in this first table will be used for training and the second one will be used for the validation. The concept is similar, somewhat like as regression, because here only differences we get is at the 1 or 0. It's not a numeric, but it's a training and validation model. Like first we train and then we validate. Next model we want to discuss about clustering, that is an unsupervised model. In this model, we're gonna break, we're gonna make the clusters, and based on that clusters, we're gonna predict the value. Here there is no concept of train and validate. We're gonna use all the data, and based on the uh, results we will predict. So how it will work we're gonna discuss now. In the screen you can see the subscriptions. There are multiple subscription which I have, and unsubscribers and the enrollments for that particular subscription for a given period of time. So for the standard I have 4 guys unsubscribing and there are 8 enrollments. For the basic, I have 5 unsubscribed guys and 3 enrollments and so on. So I have all these values on the graph. I have plotted all the values on the graph. Here on the, so you can see that values, after the plotting of the values, we're gonna analyze this. Here, how we're gonna analyze this, we're gonna make the clusters. So if you see on the first, on the first graph, the there we can see there are some similar values lying in the same area path, same area. So if you see there are 6 values, and out of 6 values, two two values in a similar area, like we can make it as a cluster or a group for that particular value. If you see, we have 2 values for very near, at the near places as seen in here. So what I did, if you see the yellow dots, I make it as a red circle on those yellow dots. Once I made those yellow values in a single cluster or a single group, then what I did, I added a 3 random dots, that is a black dots. Black dots represented the k value. So you can plot the k value at anywhere on the graph. K value is based on the assumption and assigned at random location. Here, as we have 3 clusters, because if you see we have values, we have 6 values. In subgroups we have three grouping in which the values are very nearer to each other. So we have 3 clusters. One is the above and 2 are in the middle. So like after that, I made a red circle that is a cluster, and then I made a black circle which is a k value k. The k is based on the assumption you can put it at anywhere on the graph. Once you do that, we can have a cluster specified to it. We will repeat these steps so that our cluster will stabilize or found the actual values that is a correct or not with the minimal errors. So you need to follow this process until the black circle, or you can say the k value, will become the median of these 2 values, that is the 2 yellow spots, like as shown in this figure. So we need to work like this so that the value of k should be mean for the both the yellow values, that is the both the values which we have the data, and based on this data we're going to predict the values. So to brief what we did in the clustering model, in the graph we plotted the values. Once we plotted the values, we have the similar groups, and in this case we have 3 clusters. Once we have the clusters, we pointed the 3k values, 3k, that is a black dots, that is in black. We put 3 black dots at randomly placed. After that, I made them as a cluster. I added the red circle and make it as a cluster. You can take any, it's a random thing. Once after this, you need to take the values of like the both the yellow spots and make the black dot or a black circle in between the yellow spots, yellow values. Once it is done, then only we can have a stabilized value for the k. So k should be at the centroid of the yellow, like shown in this. So once we did this, then we can say that model is in a perfect shape. So now I'm going to explain you what is supervised machine learning and what is unsupervised machine learning. We see, we saw that supervised is for the regression and the classification, while clustering is the unsupervised machine learning. In supervised machine learning, we train the model based on the labeled data set. That is, we have both raw data as well as result. We split our data into training and test data set, where the training is used for our network. In unsupervised machine learning, the information used to train, which is not labeled in a dataset. Unsupervised learning studies on how many systems can differ a function to describe a hidden structure or from the unlabeled data. The main task of unsupervised learning is to find patterns in the data. So, likewise, we did the main task of unsupervised learning is to find the patterns in the data. Like here, we are just finding the pattern. Multiple times we did like this, and then we came to this point based on the data available. So, but this is not the case in the classification nor in the regression, because here we have the value for the training purposes and then we have the validation, but this is not in the case of the clustering model. Here we have to make an analyze and then make the value to the center so that the system stabilizes, and we have to perform this activity until we get the correct values, because there is no data for validation in the unsupervised learning. In the next demo, we're going to see how Azure machine learning is, and in the next session, we're going to see the Azure machine learning demos. Thank you. See you in the next lecture.